complex numbers cluster. Rewrite root negative 32 using concepts of imaginary numbers. I don't want just an answer. I know a couple of you can do this in your head, but I don't want just an answer. I mean, just show me the process. First off, do you know, is it real or imaginary? So what are you going to put in front of it? And what's that do to the sign? Makes it positive. You cannot take the root of 32. It doesn't exist. Separate it in two pieces. And the deal is, one of those pieces you can take the square root of. You know, 8 times 4 is 32 all day long, but can you take the root of 8? You could take the root of 4, but 8's 4 and 2. So you got to go big or go home. The biggest way to break up 32, where you can take the square root of one of the pieces, is 16 twos. Now, what's the root of that 16? So 4i root 2. It's not a hard skill. There's no plus or minus here. This was not x squared equals, kids.
Why don't you put the I?
You can.
I thought it was I4.
I4 is an iPhone. A very old iPhone. Huh? That's fine, as long as your radical suggests that the I is not inside. That's why I put it in the middle. If you're typing things out, usually put it at the end, but it just looks better there, to be honest with you. This is right in standard form. This one, I don't really know that a kid would have to show a lot of work. You shouldn't have to. I mean, you add your real numbers together, what do you get? 2. Negative 3 and 5 makes 2. If you add your imaginary numbers together, what do you get? Negative 1. So just minus I. It's not a hard problem. Now, I'll show you something. Now, I'll show you on C. I mean, there's no reason you can't get C right, but you're going to have to show me the proper work to get credit for it. This is just foiling, isn't it? You know, 4 times 5 is 20. 4 times 3i is plus 12i. Negative 2i times 5 is minus 10i. Negative 2i times a positive 3i is what? Negative 6i what? Squared. You don't stop there. You're not done. This negative 6i squared is really a negative 6 times a what? Negative 1. Which means that it becomes positive 6. I'm just going to do mark out here and put it there. Show me that you did it, though, wherever you do it. I'm not saying write a whole new line, but show me that you made that a positive 6, okay? That's what it is. And then put your like terms together. Reals first, 20 and 6. What do you got? You got 26. And you got a positive 12i minus 10i. What do you got? 2i. Your calculator can do this. If you're curious if you got this question right, and it could have done part B as well, you just go to your calculator and you type it in. 4 minus twice an I. Where's that I button? The period. Again, I got to see it. I got to see you foil out, kids. When you do a problem like this on EOC, you don't have a calculator in front of you. It is not available to you. Plain and simple. It will be by hand. And it will be on your EOC. It's been on your EOC every year for a long, long time. 26 plus 2i. Check your work right now while you're young. Looks like we did it right. Find the conjugate of. Of course, it's got that word in there, conjugate. To form a conjugate, what do? Change the sign. In this case, in front of the imaginary piece. Change the sign on the imaginary piece. So what is a conjugate of 3 minus 5i? I'm sorry, of negative 3 minus 5i. There we go. All right, you got a little exponents cluster. This was Monday's or Tuesday's lesson. No, one of those 2 days. Anything special about A? Anything stick out? Makes you know the answer immediately? 0. You have something, and who cares what it is, raised to the 0 power. What's it got to be? 1, by definition. Don't be the kid who misses that, especially when you're going to have a piece of paper in front of you. It's going to happen. It is. All right, I wish they were all that easy, but they're not. You've got an exponent outside. You've got stuff inside a set of parentheses, and you've got an exponent outside the parentheses. What are you supposed to do with that outside exponent? Kind of distribute it in. You're multiplying it in. So I have x to the negative 1/2 times a 3 up top. Sorry, that's a negative 1/3. X to the negative 1/3 times a 3 up top. Sitting over a y squared times a 3. Now, what is a negative 1/3 of 3? What's a third of 3? What's a negative third of 3? It's x to the negative 1 over y to the 6th power. Is that done? No. Rewrite so that all exponents are positive. Something has a negative exponent, where do you put it? Move it to the bottom. Put the understood 1, leave it up top. 1 over xy to the 6th is your answer. Well, you don't have to show it originally, but once you move this guy down low, you need to leave the understood 1 where it is.
No, you have to show it if it's a negative exponent.
You don't have to show it if it's understood. You can. I'm not going to count off for it. I probably should. It'd probably make kids understand better, but some things are supposed to be understood. All right, C will probably go pretty good. It's not multiple choice, but I'd focus on the numbers first. What's 6 over 24? 1 over 4. So I have a 1 up top, 4 down low. I don't really care if you show all the work on this. I'm not going to. But we have an x squared over an x to the negative 3rd. I guess I will show it. No, it's not. The second piece was x squared over x to the negative 3rd. No, the text is kind of small there. How do you handle division? Subtraction. Division is handled through subtraction. So from the exponential space at the top, you take away a negative 3. And you get x to what power? It's 2 take away negative 3. 5. X to the 5th up top, that was positive. The next little grouping I got is y to the negative 2nd over y cubed. You can take away from the top if you want. Want to take away from the bottom? So 1 over y cubed minus a negative 2. It's all about subtraction, kids. Wherever you take away from, you're subtracting. 1 over y to what power? 5th. And notice where it ended up at, right? Ended up in the bottom. Keep it in the bottom. Last thing we have is z over z to the negative, I believe that's a 2. I really don't feel like showing the work on that one. Z to what power? 3rd power. 1 minus a negative 2. Z cubed. Positive up top. I actually meant for the next problem to be harder than it is, but I edited it and I forgot to hit save. So you get what you get. So it's easy. What do you do with 5? Distribute it. What's your answer? M to the 5th, n to the 5th. Quit saying M5, N5. It doesn't make a lick of sense. If I told you to write down M5, N5, what would you write down? You put it on a script level, them. Not the superscript, there it is. Exponents are superscripts. M is a script, it's on the level. There's what you call a subscript. Like when we do x1, y1, those are down level, those are called subscripts. All right, oh, we have a section with a calculator. That's nice. Vertex and roots with a calculator. So I guess we need to have a calculator on. And you can try watching, I don't know. Some of y'all, you know what you're doing already. You can actually get away with watching. Some of y'all Can't. All right, so I'm in y1, negative 7x squared minus 4x plus a 2. That's all I'm going to type in. Because the questioning is about, I might do something more for B, but the questioning on part A is what are the coordinates of the vertex? I think this thing is supposed to work with a standard zoom 6. I didn't bother changing that problem. Ah, sucks. I actually have to redo some stuff here real quick. Why don't you guys spend about 3 minutes and see if we can figure out 3 and 4. I forgot that I didn't do something. That did show up on a zoom 6, didn't it? I thought it was supposed to. What are you doing? How many of these do I need? How many kids are in here? About 20? All right, so anyways, I'm back. Sorry about that. You guys about had way too easy of a quiz because I forgot to modify problems. Anyways, second calc, what? Maximum? You get left, enter. You get right, enter. Enter for a guess. About negative 0.29 for x and 2.57 for y. Huh? Oh, your zeros and roots. Well, to do that, you had to actually put, don't. Use calculator, son. Whatever it says, round. What do you have to put into y2 to find the zeros and roots? You have to put a 0 into y2. You have to do that. So you go to y2 and you throw in a 0, and then you do your second trace 5 to intersect. And you'll get your little cursor close to a left zero and you'll press enter 3 times, enter, enter, enter. There is a root, negative 0.89. There's another one, it's right over here. Second trace 5 again. Get it close, enter, enter, enter. 0.32. All right, then you got a little factoring cluster. And I wish I had more time to explain this, but I'm running low on time. This is factors of C that add to B. And I think there's actually a problem with this one. There is. It won't factor, actually. What I gave you here is non-factorable.
Yeah, I just tried.
We're going to change the 18 to be positive. Now it is factorable. Because factors of 18 are 2 and 9. And to get to a negative 11, they both have to be what? Negative. Now, if you do that, what are your roots or your zeros? Yeah, 9 and 2. We're just going to say x equals 9 or x equals 2. You can give me an ordered pair if you really want to. Now, part B is not intended to be that bad. There's only one way to create a 5x squared. 5x times x. Okay? Factors 12 are 3 and 4 all day long, or 2 and 6. It's probably going to be 3 and 4 somehow. If I link up the outside, I get 20. If I link up the inside, I get 3. Okay? I can get to a 17 with those numbers. If the 20 is negative and the 3 is positive, I'll get to a negative 17. That's how that guy factors. You got an easy zero of x equals 4. This one's a little bit harder. You know, you're thinking 5x plus 3 is 0. That makes x a negative 3/5 when you subtract 3 and divide by 5. Then you got the last one, which is a very special pattern. It's a difference of 2 squares. It's an a squared minus b squared pattern. That's what it is. The square root of 9x squared is 3x. It takes a 3x and a 3x. The square root of 49 is plus and minus 7. All you do is you take the square roots of both pieces and you got it factored. A little more work on these. Remember, you think about being equal to a 0. You're going to add 7 divided by 3, 7/3. Subtract 7 divided by 3, negative 7/3. And then lastly, you have this guy right here, the right equations cluster. So for the parabola left, assume A is 1 and give its equation in vertex form and intercept form. All right. This is probably, yours looks much better on the quiz, is probably at 2, negative 1. Now you have to remember vertex form, but it's y equals a times x minus h squared plus k. Now what am I telling you that a is? 1. I'm looking here at my vertex. My vertex gives me h and k, so x minus what? 2. All squared, and then plus k, but k is negative 1, so minus 1. Intercept form is y equals a times x minus p times x minus q. Well, there's p, there's q. All you do is plug the numbers in, kids. So y is that understood 1 times x minus 1 times x minus 3. It really stinks because I don't think you'll finish. You won't. Anyways, why don't you start on it, and I'll give you about 5 minutes of class tomorrow to finish it, okay?
Look at my calculator when you get over here.
Why don't you start on it, make sure you put your name on it, I'll give you about 5 minutes of class time tomorrow to finish it. Shouldn't take you long. In fact, some of you might have some class. So real quick. The last one is x minus 1, x minus 3. Yeah, just make sure you put your name on it. I won't grade it today. But I'll give you about 5 minutes from the class tomorrow to finish it. Hannah, the most important person. Oh, you're good, buddy.
That's why I was trying to find out.
But zero, I want to.
Okay.
Nice.
Nice. If I could put it in there, it wouldn't be.
Intersect only works if there's 2 points. Gotta have something to intersect. All right, let's go faster in this class. The video has to be, it can be kept.